Okay guys, so as you can see, this was my paper for when I was trying to follow some of your transformations to get A, B, C, D to land on Q, R, S, T. And it was kind of challenging, right, to describe things. There was no X and Y axis here, and there's a lot of freedom, but you guys did a great job. So I had a lot of students start with translating. So they would translate to the right 10 and up 2 to get A to land on Q. And then maybe some rotation would happen here, maybe some reflection, maybe reflecting over that line there, some different things. I had a couple students maybe start out with saying, okay, well, let's just reflect it over AB. Instead of trying to find a line, let's just use one that's already here. So then we know A and B will stay in the same place, and these ones will flip. So I thought that was really helpful to try and just use lines that already existed. I thought that was awesome. I had one student, it was near the end, I think. It was something like this. They got it to this point by some translation and rotation, and then said, well, let's reflect over A to C. So A and C would stay in the same place, and then B and D would end up landing on top. So I think that there's some really powerful things that we can learn here. So I'm going to get a blank one so we're not distracted. Okay. One of the best things we can do is use things that are already there. So everyone did a great job at trying to find sequences of transformations that will get one shape to land on the other, but it was very specific to these two shapes, right? Go right 10 up 2. Reflect over the line y equals x, or a straight vertical line, or a horizontal line. So we want to come up with a way that's going to work for any two shapes, so that in essence we found an easy way to do this that will work for any shape and not just this specific set. So I like the idea of what a lot of students did was essentially take A to Q. Now if I said translate A till it lands on Q, even though I didn't give any units, would you be able to move that? And the answer is yes. I can just say, oh, well, perfect. I'm just going to go like this. A to Q, donezo. Okay? Then what if I rotated around this point that's now common between the two figures? What if I rotate around this point until a side matches up? So I could either go this way, rotate around A. Oops, let's do that a little bit better. Rotate around A until B and R line up. Or we could, well, let's do that. So then you see now we've got this line that matches up, and we could do what the other student did over here. We could reflect over AB. So do you see how I didn't create anything new? I didn't create any new lines, any new center rotations. They already existed. And I can do this for any figure. So we could even do it, let's say, let's see, D lines up with T. So we could translate D to T. However far that unit is, you can still perform it, even though we're not specific on the units. And then we could rotate around D until A lines up with Q. And then reflect over DA. Do you see that? Okay, so we could write this. Let's write this down. I want you guys to copy this down. Write this down. So let's start. We translated A to Q. Donezo. Then we wanted to rotate around A or Q until, because the key about giving a direction in degrees is that we know when to stop. But so we need to say when to stop. Okay, so we're going to rotate, and it doesn't matter which direction, right? As long as we say stop when B reaches R. So I could go the long way, or I was over here, and I can go this way. So it doesn't matter the direction now, as long as I know when to stop. So until B lands on R. So now we know A is on Q, B is on R, so now we've got this matching line, and I didn't draw it, but if we come over here, A to B has one tick mark, and so does Q to R. So we know they're the same length. Then we can just reflect over AB reflect over AB. C landed on S. And D landed on T. So, ABCD is congruent to QRST. Notice that A landed on Q, B landed on R, C on S, and D on T. You want to do them in the same order that the points show up. So this right here, this is what you need to know, that we can translate a point to a point, then rotate around that point until a side matches up, and then we can reflect over that side. And this will work for any two shapes. So now, if I were to move Q up here, this will still work. It's vague but specific enough that I can follow, but that it works for any two shapes.